We are going to solve this differential equation by applying Laplace transform on both sides of this equation and apply differentiation property when finding the Laplace transforms of the derivatives. Now I'm going to be applying the initial condition y of 0 here and here, and y prime of 0 here. Then I'm going to be making y of s the subject of the equation by factoring it out, and eventually I'll find the answer by taking the inverse Laplace. We know that the Laplace transform of t squared is 2 divided by s cubed. So using the shifting property, I'll write the answer directly. Now, I'm going to be making y of s the subject of the equation, but before going any further, I'm going to first factorize s squared minus 6s plus 9. Writing s minus 3 squared directly, and adding these two gives positive 6. Now I'm going to be making y of s a subject. I'm going to be taking s minus 3 whole squared to the other side of the equation. Now, this s minus 3 and this s minus 3 is going to cancel out. Then, to find the value of y of t, you're going to be taking the Laplace inverse on both sides of the equations. Now, let's apply the linearity property and find the Laplace inverses of each of these individually. Now we are going to multiply and divide by 4 factorial because the value of n is equal to 4, which we can determine from the denominator. After, we are going to write 2 divided by 4 factorial t power 4 because value of n is equal to 4. We know that e is going to be e power 3t because it is s approaching to s minus 3 written outside the Laplace inverse. This is going to be giving us our final answer. We are going to apply the Laplace transform on both sides of this equation. And using the differentiation property, we'll be taking the Laplace transform of the derivative. Let's do that. You can see that the values of all the initial values is 0. So let's rewrite this equation. You can see that this is a cubic expression. So let's factorize this as working 1. You can see that I have directly substituted working 1 into this equation and found the partial fractions, the values of a, b, c, and d, and substituted them into y of s. Now to find the value of y of t, we are going to take the inverse Laplace transform of this equation. I am directly going to apply the linearity property as well and find the inverse Laplace. The inverse Laplace of 1 divided by s minus 1 is e power positive t. For s minus 2, it is going to be 1 divided by 2 e power 2t. For s minus 3, it is going to be 1 by 2 e power 3t. And for s minus 4, it's going to be 1 divided by 6 e power 4t. And this is going to get us our final answer.